Before that, just think about the word address. Every home have some kind of address. But question is this: why do we need this address? Address is used to assess any home. It uniquely identify any home so that it becomes reachable. Similarly, computer needs some address to assess operands so that operation can be performed. So, the different ways by which operands can be addressed are known as addressing modes of instructions. First of all, immediate mode. In this type of addressing mode, the operand is specified in the instruction itself. This type of addressing mode has an operand field rather than an address field. The operand field contains the actual operand to be used. Like, you drop somebody exactly at the home, so no need to give address. Example, load R #1000 loads the value 1000 directly in register R. The source operand is given as 1000 and not the address, and destination is the register R. Any change in the value of an operand requires a change in every instruction that uses the immediate value of operand. Next is direct address or absolute mode. In this, the address of the memory location that stores the operand is included in the instruction. Example, load R 5000. This instruction loads the value of operand stored in memory location 5000 into register R. Here, the source operand is the value stored in the memory location with address 5000. A and the destination is the register R. Next is indirect addressing mode. It is a flexible addressing mechanism. The address of the source operand is not included in the instruction, but rather register or memory location. Register or memory location is in parentheses. That holds the effective address of the operand is given. Consider the instruction load R 1000, the memory location 1000. This instruction loads register with the contents of the memory location whose address is stored at 1000. There can be two variants. Register indirect addressing, if a register holds the address of the operand. Memory indirect addressing, if a memory location to hold the address of the operand. Next one is indexed mode. Here, the address of an operand is obtained by adding a constant to the content of the index register. Consider load R 1000 loads register R with the contents of the memory location whose address is the sum of contents of register index. Let value in index register is 100. So, address of operand will be 1000 plus 100 is equal to 1100. Means operand is at location 1100 in memory. Relative mode. Relative addressing mode is similar to indexed mode, except that program counter PC register replaces the index register. For example, instruction load R. 1000 loads register R with the contents of the memory location whose address is the sum of the contents of the program counter PC and the value 1000. Suppose value in PC is 200, then address of operand will become 1200. Next is auto increment mode. It is similar to register indirect addressing such that effective address of operand is the content of auto increment register. Auto increment register is given in parentheses. Content of auto increment registered is incremented after assessing the operand. Auto increment is indicated by including a plus after the parenthesis. Consider an instruction load R. R auto plus loads register R with the operand whose address is the content of register R auto. After loading the operand into register R, the content of register R auto is incremented, pointing, for example, to the next item in a list of items. Auto decrement mode. In this, content of auto decrement registered is first decremented and the new content is used as effective address of the operand. Minus is included before the indirect parenthesis to show the decrement of auto decrement register before assessing the operand. Example, the instruction load R auto, decrements the content of the register R auto, and then new content is used to compute effective address of the operand to be loaded into register R. So, these all are the types of addressing modes. Thank you.